Right. Okay. So this is the third part within the lectures of your carbon literacy training. We've been discussing about this from week 2, and then we did a little bit on week 3, and this is week 4. Next week is going to be the final week of carbon literacy training, and then we'll move on to the various topics of this module. Next week, I'll be discussing about some of the broader solutions that we can come up with regards to climate change and the solutions related to it. So this is going to be a shorter section. Last week, we talked about two important things. Number one, we talked about what is carbon footprint. So the total emissions that come out of our activities. And then we talked also about climate justice as a concept. So just to recap about what we did. So carbon footprint is the amount of greenhouse gases released into the atmosphere by a person, organization, product, or activity. So it's not just about individuals. It can also be about everything, about countries, about organizations. So for example, if you were able to estimate and calculate all the emissions that come out of everything that we do within Scotland, you are able to calculate the carbon footprint of Scotland as a country as well. If you wanted to calculate the carbon footprint of the whole of the UK, you can do that. You can do that for the whole of Europe. You can do that for the whole world. You can do that for organizations. Like, for example, you can calculate what's the carbon footprint of GCU. And that's also quite possible. You can calculate what the carbon footprint of Apple as a global company is, or as Samsung as a global company is, or to something as small as you as an individual. And even if you break down our activities as individuals, we're able to calculate simple things like how much emissions are generated as a result of you sending a Snapchat message to your friends. How much emissions are generated as a result of posting something on Instagram, for example. How much emissions are generated by sending an email or a WhatsApp text message or something like that. So even as small as that to something like if I'm flying from Glasgow to London, how much emissions are going to be emitted. So you can calculate the total amount of greenhouse gases released into the atmosphere by a person, organization, product, or activity. Now, when we say greenhouse gases, what are we referring to? It's a family of gases. Can somebody just quickly tell me about what gases are we talking about? Say again, sorry. Yep, thank you. Yes, absolutely. So CO2, there are 5 of them. CO2, carbon dioxide, there's nitrous oxide, there is CH4, methane. You also have water vapor, which is simply just water. And you also have chlorofluorocarbons. And the difference between the first 4 and the 5th one is that the 5th one is actually man-made chemical, and the other ones are naturally occurring. So when you burn something natural, like for example coal, you emit CO2. Okay, but your chlorofluorocarbons are coming from 2 sources. One is your deodorants, so compressed gas, and then your refrigerators. But that's a very small percentage, but they harm quite a lot the environment. Okay, so that's really important. So just to recap, the carbon footprint is the amount of greenhouse gases released into the atmosphere by a person, organization, product, or an activity, any activity. And we know now the means to calculate that carbon footprint, and we'll do that in our seminars over the week, next week. A larger carbon footprint means more emissions of carbon dioxide. Or in other words, more emissions of carbon dioxide or other greenhouse gases means a larger footprint. So once we know that, we're able to control that. So for example, compare a journey between Glasgow to London by 3 different means: by driving, taking the train, and taking the flight. Now, if you knew that my individual carbon footprint is high because I've always taken the flight to London, you're able to change that behavior by saying that next time when I go, I'll probably take the train. And so therefore, what you've done is you've cut down your emissions by doing so. But you can't do that until you actually knew what my emissions are by doing different things. So for example, if I knew that the energy that I use in the house is coming from uh, non-renewable sources like burning coal or gas or something else. The heating that I do in the house is coming from those. And if you realize that and you said that, okay, I want to change that because I want to reduce it, I'll change to renewable sources of energy, and then you'll be able to find a supplier who actually supplies electricity created from renewable sources, and by doing so, you're able to cut down on your emissions. Something as simple, not me, something as simple as boiling water in the kettle, right? If you were to drink a cup of tea, it's a very simple thing. It probably will save almost minuscule amount of energy, but it's important to understand our actions and behaviors. If you were to make a cup of tea, only a cup of tea, but you filled your kettle to the brim, the amount of energy and time it takes to boil that water is enormous. And out of that, you're only using 1 cup of tea, which means that if actually you heat, and that's most people's habits. They actually fill the kettle more than what they require. And so every time, let's say, for example, you're making 4 cups of tea in the day, you're actually heating up that water every 4 times. Instead of that, if you only took water that is required for you at that point of time, you will most likely reduce your CO2 emissions. Simple things like that. For example, your washing machine, how often you use it, and what temperature do you use it. There isn't really much difference between washing your clothes at 60 degrees and washing your clothes at 40 degrees. It'll still wash them equally well, but you'll use less energy. Try a cold water wash the next time, and you will find that the energy requirement is much lower and the clothes are still equally as clean as they were using 60 degrees of water. So think about these small changes in behavior, and that'll actually help us to reduce our carbon dioxide emissions and methane emissions, and that'll reduce the overall carbon footprint that we have. If all of us in the whole country start to do that, little savings will save thousands and thousands and thousands of tons of CO2 every year. And that's the whole idea. We have power in a collective effort, much more than individual effort. And that's what this next week's seminars are all about. Try and calculate our own individual carbon footprint and try and find ways in which we can reduce it. So the objective for us now is to be able to reduce that carbon footprint by changing the habits that we have. And there are 3 areas in which we can change our habits. Number 1, the way we travel. Number 2, the way we live in our houses, energy use. And number 3, what could that be? Where else can we change our behavior and reduce emissions? Where is methane coming from mostly? The way we eat. Thank you. Yes, so the food that we consume, particularly the meat that we consume, produces a lot of methane from the animals and the farms and that sort of thing. So if we're able to control and change our behavior in these 3 areas, we are able to collectively reduce the carbon footprint of us as individuals, collectively as a society, and collectively as a country. And that will have a huge impact in reducing the temperatures and meeting the Paris climate targets. What was the Paris climate target? Question number 3 on your quiz. Who remembers it? Say again. Net zero by 2050, that's correct. Specifically, keeping the temperatures down below 2 degrees average temperature rise by the end of the century, and doing everything that we can to reduce it to 1.5. So we need to control the average rise of temperature to 2 degrees maximum, and then to do everything that we can to reduce them to 1.5 degrees. That's one of your quiz questions, remember, right? We also talked last week about breaking that down into 2 categories. We talked about what is production-based carbon footprint accounting and what is consumption-based carbon footprints. And we then discussed that production-based carbon footprint was all the emissions produced out of all the activities that we do within our national boundaries. So if you were to calculate the carbon footprint of the UK, you would then look at all the activities that we do. So transportation, oil production, all the manufacturing that we have, very limited, but we still have a lot of it. Manufacturing, textiles, use of cars and buses and burning of fuel and use of energy, et cetera, et cetera, et cetera. All of that is the emissions produced by activities within the country, And that's called production-based accounting. We can add up all the emissions that are produced within that country. However, a lot of critics have said that that's not a true measure of a company's emissions, of a country's emissions. Why is that? Because we don't consume everything that we produce, we consume a lot more. And over the last 20 to 30 years, our consumption has increased. But is whatever we are consuming produced within the UK? Most likely not. The chances of that not being produced in the UK is much higher. And you can think about your clothes, your laptops, your phones, the projector, the computer screens, and everything else that we use, the food that we eat. Most of the consumable products are coming from outside. Quite a lot of our food is coming from outside as well. So you got to be able to understand that the entire life cycle of that product and the emissions are connected to us when we buy and consume that product. And so therefore, there is a requirement now that we must move from production-based accounting of carbon footprint to consumption-based accounting of carbon footprint. So we could add up all the emissions associated with the goods and services that we consume within that country, even though those goods might have been produced elsewhere and transported all the way. And the associated emissions to that is my emission. I can't really say that, no, I'm consuming this piece of cloth. It is manufactured in China, and so therefore it's not my responsibility to calculate that as part of my emissions. We must calculate our consumption-based carbon footprint always, and that gives us a true measure. And then we moved on to another topic called what is climate justice, okay? And we discussed that climate change, or the impacts of climate change, are not proportionate to everybody in the world. And I took an example last week, which probably, it's probably more related to you than other examples that I've taken. So climate change impacts different people in different ways. So for example, somebody living in the developing world is impacted by climate change in a different way as compared to somebody living in the developed world. Okay, as it like to differentiate between the global north, the developed world, and the global south, the developing world. So it's really important that we differentiate that and try to understand the impact of that as well. People in the global south are more vulnerable to the changes in climate as compared to people in the global north or developed in the developing world. People who are poorer are more negatively impacted by the changes in climate change compared to people who are more, who are more wealthier. People who are educated may be less impacted by climate change as compared to people who are less educated, because the chances of being aware, for example, yourselves, you're now more aware of what's happening in the climate change and sustainability than somebody who wasn't coming to do a degree. The chances are much less. So people who are educated, but the most important one is that all these people who are being affected more are more likely contributing a lot less to climate change compared to the other group of people. So it's an educated group of people who are probably in better jobs and earning well are actually contributing because of higher consumption. People living in the developed country are contributing a lot more to climate change compared to somebody living in the developing countries. And we've seen those examples in our seminars this week. For example, somebody living in Bangladesh who's contributing a lot less to climate change globally than somebody living in Australia, for example. However, somebody living in Bangladesh is much more affected by the changes in climate change as compared to somebody living in Australia. So this is the difference. But the key important example that I think will be more realistic for you is that people between generations are affected differently by climate change. So if you compare myself, let's say, to yourself, who has contributed more to climate change? Of course, yes, because I've lived longer. Okay, and so therefore my contribution to climate change is much more. But who is affected by climate change more? Your lifespan. In your lifespan, you'll be affected a lot more. So clearly there is a disproportionate impact. That I have contributed more to climate change, but I'm affected less. You've not contributed to climate change in your lifetime so much, but you're affected a lot more than me. And that is where the differentiation of impact is. That you're contributing less but affected more. I'm contributing more but being affected less. And so therefore, what a lot of people are saying, that climate change must not be thought about or understood as simply an environmental problem. It must be also looked at as a social and a political problem as well. And so therefore, all the solutions that we must find for climate change must be fair and just for everybody. So climate justice means finding solutions to the climate crisis that not only reduce emissions or protect the natural world, but that do so in a way which creates a fairer, more just, and a more equal world in the process. It's really important. Okay. I want to show you a little video here to explain what climate justice is. I'm going to go back to here, stop sharing, share again, include sound.
In the Philippines, we lost more than 10,000 people in 2 hours. The waters are rising and warming. We are catching less fish. Have you heard stories like these? The Philippines is one of the most vulnerable countries to the impacts of climate change. Since the Industrial Revolution began 200 years ago, gases like carbon dioxide and methane have been slowly building up and warming the planet. They are the products of industrial human activities like deforestation, agriculture, and most of all, the burning of fossil fuels like oil, gas, and coal. Today, we need to ask ourselves, what can we do about it? In 2015, a group of brave Filipinos took the lead and filed a landmark petition with the Commission on Human Rights of the Philippines to claim their right to a stable climate. Because of their petition, groundbreaking public hearings are happening in the Philippines, New York, and London this year. 47 big companies, including Shell, Exxon, BP, and others, are being investigated. They have been invited to face communities, but none of them have showed up so far. We need to hold them accountable, because the outcome of this case can spark hope to vulnerable communities everywhere and give them strength to take action. It will not only benefit the Filipino people, but all of us. Must we wait to lose another loved one? Must we wait for bigger and stronger storms? Must we wait for another tragic story until we reach climate justice? This is our climate story.
You can find many such videos on on YouTube. All you have to do is search for them, and that will be hopefully giving you a lot more information. I'll take a pause here just to show you something. If you want to increase your knowledge, and I'm of course also telling this to you from Coursework One perspective, if you go to BBC, and there is a whole section about climate actually now, that'll give you a lot of information, and there's news updates every single day. For example, there's news about the UK to finish coal power after 142 years. So 2 weeks ago, the UK completely stopped its reliance on coal-based power energy creation. So imagine the amount of emissions that we were creating because of burning coal for energy use. We've changed that now. Okay. We do burn rubbish actually. Instead of putting them in landfills, actually we just burn them, and we produce a lot of energy from there. But the amount of CO2 emissions coming out because of burning landfill is quite a lot. You can look at analysis of the hurricane season in the United States, for example, how that's changed over years, and how is climate change affecting it. There are some basics here as well. For example, what does net zero mean? And that could be something that you can use as a starting definition of your coursework 1, question number 1. Start with the definition of what is net zero or zero carbon, and that'll give you a good start. Okay. How is climate change linked to extreme weather? We've been talking about flooding and hurricanes and all that, and we might look at them as standalone things, but that's not necessarily true. They're all connected. Changing weather is changing our weather system, and that means there are more floods, there is increased storms, increased frequency of storms, and increased intensity of storms. That's going to cause much more damage than what it has done in the past. What can you do to reduce carbon emissions? There are the solutions that you can think about for your question 2 and question 3. And there are lots of other things that you can see on this site here. Okay, so simply just search for BBC Climate, and you can see that there are lots of different resources that can actually give you a new news is coming up every single day, and that'll be quite helpful. So that was a bit of a detour, but that'll be helpful for your coursework 1, and of course for your quiz questions as well about climate change. Right. So we're going to be finishing in the next probably about 5 or 10 minutes. So carbon footprint, what is the average consumption-based footprint of a UK resident? I think we discussed that in the first lecture, but generally speaking, any idea? I did mention that in the class. What is the average consumption-based carbon footprint of somebody who lives in the UK? 13 tons, that's correct. Thank you, you remember it. So 13 tons of CO2 per person in the UK. That may have reduced slightly or may have gone up. I'm hoping that it has reduced a little bit over the last couple of years. It may be about 11 to 12, but most estimations say that every single person in the UK emits about 13 tons of CO2 every single year. And that's coming from the activities that I mentioned, but from our travel, from the food consumption, from the energy consumption, and from the things that we buy. Okay, your TV, your laptops, your clothes, and furniture, everything that you buy in the house is all coming from purchases. Then you got your travel, then you got your food, and then you got the way you live in the house, your energy consumption. So 13 tons of CO2. To understand that, I mean, this is a simple kind of analogy, an example. If you consider that 1 ton of CO2 can fill up 5 double-decker buses to the brim with carbon particles, that's 1 ton of CO2. We're actually consuming that many. Every single individual is consuming about 13.2 tons of CO2 equivalent every single year. Okay. And then it's broken down into multiple parts. How much do we consume in the house? How much do we consume by traveling? How much do we consume by food, purchases, and using of public services? So all that is broken down, and every single person in the UK can fill roughly about 66 double-decker buses with the carbon production that we do. What we need to start thinking about is in what areas of these 5 places can we cut down? Can we change our behavior so that we're not emitting as much? And I'll give you some examples next week as to what I've done as a result of carbon literacy training as well now. Okay, let me give you one example right away. Traveling. So I live in Edinburgh, and traveling to Glasgow, of course, requires I can either take the train or the bus or you can drive. Now, I used to drive every single day, 4 days a week roughly, to Glasgow from Edinburgh. That's a 100-mile round trip. And then, of course, I realized that the emissions that I was producing because of my traveling was quite high. And so therefore, I had to find an alternative. However, one of the things that you will realize is that you got to find a practical solution to it. Now, I have to drop my son to school before I come to Glasgow. So if I have a 9 o'clock lecture, I can drop my son to the breakfast club at 7:30. And then if I take the train from there, it's impossible to reach at 9 o'clock. Bus, it'll probably take even longer to come from Edinburgh to Glasgow. There are 2 things I changed here. One, that I requested that my timetable be starting at 10 o'clock, so I don't have any more 9 o'clock lectures. So the university is supporting staff members in doing so. So I have a 10 o'clock lecture. What I now do is I still have to drop my son to school or breakfast club. I take him there between 7:30 and 7:45, which is closer to where I live. I then drive from there to a place called Ratho Station, which is near the airport in Edinburgh, and I park my car over there. Then I take the bus from there. What I've done as a result, I've actually reduced my carbon emissions quite significantly. And I'll show you the calculations I did for my own carbon literacy certificate that I got about 5 or 6 years ago. And you'll be able to see how I've done a before and an after calculation. And that helps me to say that I've been able to save roughly about 5,000 tons of, 5 tons of 5,000 kilos, 5 tons of CO2 just because of my travel, changes in that behavior. Now, post-pandemic, I've been traveling even less. So I've been now coming to university 3 days a week because I teach on a Monday, Thursday, and a Friday. So I come to university 3 days in a week. I have very little teaching in trimester B and trimester C. And so therefore, the total number of days that I actually travel to Glasgow from Edinburgh has reduced quite significantly. And so therefore, my carbon emissions as well. But that was a conscious change. I also then looked at some of the energy consumption. So previously, my energy provider was Scottish Gas or Scottish Power or something. And then I changed it to Octopus Energy. Anybody is an Octopus customer here? No? Think about that. Switching to Octopus or any other. So Octopus supplies electricity completely produced from renewable sources. So wind power, solar, tidal power, etc. And so therefore, by changing to something like Octopus Energy would actually completely reduce your carbon emissions because of energy use. Now, you may not have power over that. You know, somebody else is making a decision about it, or you might be living in university accommodation, and so therefore you don't have the power to change those things. But that's okay. As I mentioned, think about the practical solutions. Think about what's practical for you. I couldn't have abandoned dropping my son to school, obviously. That was not a practical solution. So I had to find a way to reduce my carbon emissions by doing both. Okay, so I spoke to somebody in the university, changed my timetable to 10 o'clock, dropped my son, parked my car somewhere, took the bus from there. So overall, it has reduced my carbon emissions quite significantly. Okay, I'll give you more examples of that as we go along. So what I want you to do as an activity in the class, with nothing serious really, I want you to organize, arrange these by least to the highest. Which one do you think is the least in terms of emission? And which one do you think is the maximum, is most? And why? So is it sending a text? Is it sending an email? Or is it sending a letter? Which one? And think about why. That's the most important question. I'm sorry about this sound problem today. Right, okay. So what do you think? Least? Which one is the least? Text message. Second? Email. And third? Letter, of course. Why is email lower than a letter? Text, of course, we understand, but of course, we need to understand what happens when you send a text. So what is involved? Where is the energy production coming from when you're sending an email? So when you do type an email, of course, you're using energy to write that email. Your laptop is plugged in or something. But the most important thing happens after that. So once you send it away, it goes to a cloud-based system somewhere, a server, and then it's kind of redirected to some other servers, and there's a network of servers and all that, and then it reaches its destination. Okay, the amount of energy that these servers are using is enormous. You can't imagine how much energy these servers use. Okay. So every time we send an email, it's not simply just an email coming from your laptop to go into somebody else's laptop. It actually travels a long distance in between. And so therefore, the amount of servers that are required to support this transition, this travel is quite a lot. But of course, not as much as a letter. A letter, of course, once you're using paper, you're then posting it, you're driving or walking or whatever, and then the postman or postwoman comes and takes it away. They takes it to a depot, they take it to a sorting office, they put it in the train or plane or whatever, and then it goes to the destination, follows the same reverse process, and then it comes to your home or wherever you've sent it to. So it requires a lot more. So an SMS uses about less than a gram. An email uses about 4 grams, but a letter uses about 200 grams. Thankfully, we're not sending as many letters as we used to do before, but the number of emails and texts we sent is quite a lot. How about going for a meeting? By tram, by taxi, on a bike, after having eaten. So remember, you're still using energy. So you have to eat something before you can drive or ride, or taking a bus. Now, I'm assuming here that the bus is probably either an electric or a diesel, I'm not sure. Tram is definitely electric. And taxi, I'm assuming here that you're going by yourself. Quick one, which one do you think is the least? Bike, yes, that's right. And second? Least? Probably a tram, electric one. Hopefully it's using renewable energy, electricity. Third one? By bus most likely, and a taxi, either a petrol or a diesel one, is the next one. You're right. Now the reason why the bus and the tram might be at the same point is we don't know about the source of electricity that they might be using, but that's probably about the right order. You can see the difference between a public transport and a taxi or an individual car as well. So you could probably equate that amount of energy being used for going for a meeting. Now it depends on the distance, of course, as well. But you can see that the bike, of course, uses less energy, less emissions than the bus and the tram and your taxi. How about this? An easy question. I've already given the answer to that before. Which one is least and which one is most? Plane, of course, would be a lot more than the train. A train would be about 120 kilos of CO2 emissions one way, and plane would be about 500 kilos or 5 tons. Or is it 500 kilos, 0.5 tons per person per travel? Now, how does it affect by knowing these numbers to organizations? GCU now hasn't really embedded this into a policy, but what they've done is they've actually encouraged staff members to say, if you're going to some place which can be accessed by train within 6 hours, then you must take the train for that. It might be converted to a specific policy where if you take a flight to a place where you could have reached by train in 6 hours, you would be denied the claim for that. So I wouldn't be able to get reimbursement for my travel for an official meeting or conference if I don't take the train, if it's reachable within 6 hours. It's really important to understand that these calculations are helping organizations to create policy now. So GCU's transport policy will be affected if you try and understand these important aspects. Okay, so that is the purpose why we are not just at the individual level, but also at the organizational level. And the final one, which one do you think is least in terms of emissions? 1 liter, let's say, of soy milk and 1 liter of fresh cow's milk. Why is that? That's correct. Methane produced from cattle, whereas soy milk is vegan and so therefore plant-based, which is less impactful, as much as 3 times more. Okay, so next time when you're going to buy milk, think about what is the contribution to climate change because of that. Okay, the cattle industry contributes to climate change quite significantly after the travel industry as well. So in next week's seminars, just hold on for one more minute. In next week's seminars, we will start to calculate our individual carbon footprint. We'll break it down into 4 parts. We'll break it down into travel, food, home, and purchases, and we will learn to use different carbon calculators. Okay, so thank you very much, everybody, for coming today. And we're leaving early a little bit, but I hope to see you next week, and I wish you a good weekend when it comes. Thank you.